The photoelectric effect, incident light, which is made up of photons, is shown onto the surface of a metal. One electron can absorb only one photon. If the photons have enough energy, the electrons will escape from the metal atoms. These escaping electrons are called photoelectrons. They are emitted with a range of kinetic energies up to a maximum value. The energy of incident photons is related to the frequency of light by delta equals hf, so it was observed that no photoelectrons were ejected if the frequency of the light was below a certain value. Observations about frequency. 1. Photoelectrons were only emitted if the frequency of light was a certain minimum value called the threshold frequency. 2. If the frequency of the light increases, the maximum kinetic energy of photoelectrons increases. Observations about intensity. 3. If the intensity of the light increases, the number of photoelectrons increases. 4. However, increasing the intensity did not affect the maximum kinetic energy of the photoelectrons. Observations. Conclusions. Wave theory states that the energy of light was proportional to its intensity, but the wave theory only explains observation 3. If true, 1. Even when frequency is below the threshold frequency, the electrons should gain enough energy to meet threshold energy. 2. The intensity should increase the amount of energy available. 3. This should increase the kinetic energy of escaping photoelectrons. However, wave theory cannot explain 1, 2, or 4. The photoelectric effect can. The photoelectric effect therefore proves the particle nature of light. Work function. The maximum kinetic energy of the photoelectrons depends on the frequency of incident radiation and the work function, phi, of the metal. This leads to Einstein's photoelectric equation, where all terms are energy terms. HF equals phi plus Ke max, where HF equals photon energy, J. Phi equals work function of a metal. Ke max equals maximum kinetic energy of photoelectrons. Ke max equals 1/2 max caret 2, where m equals mass of an electron and v equals maximum speed of the electrons. An electron deeper within a metal will have a smaller Ke max than an electron from within the surface as energy is lost. The deeper into a metal an electron sits, the more distance it must travel, so the more energy must be used to travel to the surface of the metal. Stopping potential. The maximum kinetic energy of photoelectrons is measured from their stopping potential, versus. Versus is the potential difference needed to stop the fastest moving photoelectrons. EVs equals Ke max, where E equals charge on electron, Q. Versus equals stopping potential, V, and Ke max equals maximum energy carried by photoelectrons, J.